So when we have an inclined plane, it's important for us to draw ourselves a diagram. So a block of mass 10 kilograms slides down a smooth slope angled at 15 degrees to the horizontal. So first thing I'm going to do is I'm going to draw that diagram. So I have a slope, and the angle between the slope and the horizontal is 15 degrees. Make sure we use degrees, not radians. And a block of mass 10 kilograms slides down that slope. So we have a block on this slope of 10 kilograms. Now, it's important to draw yourselves a fairly large diagram for this kind of thing because it can get rather messy if you don't draw a large enough diagram. And let's start by drawing our dotted lines. So, well, first things first, as it says at the top here, the resolve forces or the reaction forces are parallel and perpendicular to the plane that the object is on. So my reaction force is going to be perpendicular to the slope here. So my reaction force is actually going to be like this. It's a bit odd, I know, but that's to stop. That will be the force necessary to stop the object going into the slope. It has a force perpendicular to the surface itself. Then we have a smooth surface, so that's fine, but our gravity is acting downwards, so our mass has a force acting down here. So we have 10g. Now what we can do is we can instead of using vertical and horizontal components here, we can change our directions as long as we are using perpendicular planes. So the reason we can use horizontal and vertical is because they're perpendicular to each other. When we're on a slope, we can use forces in the direction of our plane or in the direction of our reaction force. So we're going to use resolve forces parallel and perpendicular to the plane itself. So reaction force is up like that, and we resolve forces in those directions. So we need to split up our weight into components in line with the plane and in line with the reaction force, like so. So you can tell you should be able to calculate from the diagram that we have an angle here of 90 minus 15, which means our angle here is also going to be 15 degrees if we have our right angle there. So from that will always be true. Our angle here will always be the same as our angle here if we're resolving our forces in the direction of the plane and the reaction force. Then we can calculate our horizontal and vertical components based on that. So our horizontal component, or the component along the plane, is going to be 10g sine 50. It's opposite our angle. And next to our angle, we're going to have 10g cosine 50, because it's next to our angle. And the 10g, our weight, is always going to be the hypotenuse of that right angle triangle. That's why it's our 10g multiplied by sine or cosine of 50. All right. So that would be our answer to A, drawing a force diagram to show all of the forces acting on the block and the direction of those forces. Let's make that clear as well. So we have, if you think about it logically, when a weight is on a slope, not all of that weight is acting downwards into the slope. Some of it's acting down on the slope and makes it slide down. That's why we can resolve forces like this. So calculate the magnitude of the normal reaction to the slope. So the first thing we're going to do and this is generally good practice, is to resolve our forces perpendicular to our plane. So we want to resolve our forces in that direction. Because we're not moving off the plane and we're not moving into the plane, so our forces are going to be in equilibrium. So R take away 10g cosine 15. Those are opposing each other, but it's not lifting off or going in, so they're going to equal 0. So therefore we can find our reaction force being 10g cosine 15. If I type that into the calculator using 9.8 for my value of g, I get an answer of my reaction force being 94.7 newtons to 3 significant figures. For C, for the acceleration, I did not write the acceleration on here, but it should be clear that the block is going to accelerate in this direction. It's going to accelerate down the slope because there's no friction. We want to find the acceleration then, so let's resolve our forces in the direction down the slope. Because that's the direction of acceleration, we might as well resolve them in that direction. So down the slope is positive. And then we'll keep our acceleration positive down the slope. So the only force acting in that direction is this component of our weight, 10g sine 15. There are no other forces affecting our movement down the slope. Our reaction force does not affect the direction of the acceleration because it's from the plane. So the only force is from the weight, so 10g sine 15, and that's going to equal mass times acceleration. Our mass is 10, so we have an acceleration we need to figure out. So 10g sine 15 is 10a, so 9.8 sine 15 is equal to our acceleration, which gets us to an acceleration of 2.54 meters per second squared to 3 significant figures.